Whoa! Would you look at that? It's beautiful, isn't it? Well, these have been a phenomena that haven't existed for millennia, really. And people have described them such as ancestors dancing in the sky or the archangel fighting a dragon. But we've come to know that there really is a scientific explanation for that. So today, we are going to learn how the Northern Lights began. So, this all begins at our favorite star, the sun. The sun is super hot, super pressurized, like 14 million degrees hot. Let's think about that for a second. And what happens there is nuclear fusion. Nuclear fusion is where two hydrogen atoms come together to form helium, and this process creates many byproducts, mainly electrically charged particles. The electrically charged particles are hanging out in the sun, and they're getting this sun all charged up, all electrically charged up, and this messes up the magnetic field of the sun. And the lines of the magnetic field begin to cross. And so the sun says, no, 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 no more of this. We want to have a normal magnetic field, and it ejects those electrical particles. And, well, they go hurtling through space at an incredibly fast speed. They're hurtling through space, they come to the Earth, bam, and they don't come in. I've never been killed by a solar flare or electrically charged particles from the Earth. Neither have you guys since you're watching my video. And this is because the Earth has a protection system that actually deflects all of these charged particles. And this deflection system is a magnetic field. The magnetic field of the Earth is created due to the fact that the Earth has an iron core. And we know that iron can create a magnet. And there is a liquid core around this iron core that moves. Magnets are created by moved charging particles. So, the Earth, due to this liquid core and iron core combination, has a giant magnetic field that connects North Pole to South Pole and is not open, it's closed, and Earth is protected. Yay! But there are some weak spots in the Earth's armor, and some of the charged particles slip their way in. Now, when charged particles travel in an electric field, they often travel in a circular path. Now, why is this? So, what happens is that when the charged particle is pulled into the magnetic field, it is then acted on by the magnetic force, which will be perpendicular to its velocity. And this means that no work is being done in this situation when the velocity is perpendicular to the force. And if there's no work being done, the speed of the particle cannot change, which sets up the perfect situation for circular motion. Circular motion is the result of constant speed with change in direction, which is exactly what we see when a charged particle is pulled into a magnetic field. But the electrically charged particles from the sun do not enter exactly perpendicular. They enter at all sorts of crazy angles, as we would expect. And so, there's something not quite circular about their path. So what we can do is we can say that as they enter, we can break it down into vectors. There is a vector that is perpendicular to the magnetic force, and there's a vector that is not. The vector that is perpendicular to the magnetic force will still be equal to 0. There will be no work done, and it will want to travel in a circle. But there will be another part that will want to travel in a different direction, and this leads to a spiral effect. The particles will begin to spiral. And something interesting is that when a magnetic field is so strong, it will start to spiral back on itself. When there is so much energy happening, that's what happens, and we see that on the Earth. These charged particles will begin spiraling, and they will spiral back on each other, and back, and they'll get all grouped up at the poles. So at the poles, we see all these energized, charged particles hanging out. but they're not the only things there. This magnetic field is in our atmosphere, where there is nitrogen, there is oxygen, the things we need to live. And just like when we're at a packed dance party, they start to share things. You know, when you're at a big dance and they all start to go off, you're all fist bumping together, you're sharing dance moves, you're sharing sweat, you're sharing breathing air, you're sharing all sorts of things. You're sharing words. So that's what happens here. It's like the molecules of the atmosphere and these charged particles are all at this big dance party, and they start sharing. The electrically charged particles share some of that energy with the nitrogen and oxygen and bring them to excited states. But nature doesn't want to be in an excited state. It wants to be in equilibrium. It wants to be in its normal place. So the nitrogen and the oxygen actually release that energy, and they release it in the form of photons, otherwise known as pockets of light. So the nitrogen releases photons at exactly the wavelengths of blue and deep red, and the oxygen releases it in wavelengths of red and green. So I think you can see where we've reached. These oxygen and nitrogen molecules release these, and we see them as the northern lights. It really is amazing how something as far away as the sun can lead to something as beautiful here on the earth. So, just as a quick little recap, what happens is the sun releases electrically charged particles. Some of them are deflected by the magnetic field of the earth and some of them are not. And the ones that are not are trapped in the magnetic field and are spirally moving, and they bump into the molecules of the atmosphere, oxygen and nitrogen. They excite the oxygen and the nitrogen, and then the oxygen and the nitrogen release that excitement in lights. In very beautiful lights. I, for one, am very grateful for this process, and I'm very grateful that science works itself into so many beautiful things.